let's talk about graphical user interfaces. There are a bunch of different ways of doing graphical interfaces for your programs. There are one set of choices which will work well in the context of a program that you run. Then there's another set of choices you can use in web-based environments. General statement here, graphical interfaces, you can do them well or you can do them fast, and you can't do both. There are no ways of making fast graphical interfaces that are really designed well and will hold up under heavy use and that sort of thing. So there are 4 general toolkits which are accessible from Python for building graphical interfaces for writing programs. And these are tools that I would say for doing it properly, writing programs that have graphical interfaces and they can be robust and that sort of thing. My own personal favorite is PyQt. I've used it fairly extensively for about 20 years, and it's a nice cross-platform tool. It's very nicely designed. It is a semi-commercial package. It's free for open source software, but if you want to write your own software, then you have to buy developer seats. If you want to write commercial software, you have to buy developer seats for it and stuff like that. But it's been around for a very long time, and the free for open source software is actually written into the license in a very legal way. So Qt is the basis for things like the KDE environment, which is one of the standard environments on Linux-based machines. So it's a very widespread, very robust, nice system to work with. Tkinter, on the other hand, comes with Python. So on any platform where you get Python, Tkinter will normally be provided and functional. There have been a few instances in the past where specific versions of Python it was broken on some platform or another, but generally speaking, Tkinter is always there. On the downside, it's a really, really clunky system, and we'll talk more about that in a second. Then there are 2 other choices, WXPython and PyGTK. GTK is used by the GIMP software, which is that Photoshop equivalent that I've mentioned a couple of times in the class, and it's a fairly popular choice for a lot of things. I'm not going to talk about those anymore today. They're also, not unreasonable choices for writing graphical interfaces. If you want to do web-based stuff, there's JavaScript. You can write interfaces, making use of JavaScript tools. We'll talk about that. All the things with stars next to them we'll talk about today. And then a fast approach would be to use ipiWidgets, which is something you can do within a Jupyter Lab session. So if you want to make just sort of quick interfaces where you have a couple sliders you can drag or something like that within a Jupyter Lab session, you can use this. Obviously, you can't use this with your class project because your class project has to be a standalone program. Now, you could make use of JavaScript if you wanted to and have use of that. You just have to include some sort of web serving capability in your class project if you wanted to do that. All right, so Tkinter. The Python interface to Tkinter is pretty well designed and very nice, but Tkinter is built on top of TK, which is which is built on top of TCL. TCL stands for Tool Control Language, and TCL was basically the Python of the 1980s. It was one of the earliest scripting languages. So in the 80s, they developed TCL, and they said, we want to have this capability of developing nice, simple user interfaces for TCL, so they devised TK. So TK sits on top of X Windows or whatever graphical capability your machine has, and provides widgets and stuff like that. And it's written in TCL, the scripting language. Tkinter uses an installed TCL-TK combination and wraps that into Python. So whenever you do something in Tkinter, what it's doing is the Python scripting language is running TCL code using the TCL scripting language to generate all the TK stuff. So you have a scripting language talking to another scripting language, which then talks to the windowing system on your computer and produces the widgets on your screen. It is very clunky. It's not super fast, but machines are fast enough nowadays that you can pretty much ignore any speed issues you might have. And some very large applications have been successfully written using Tkinter. UCF Chimera UCSF Chimera is a nice molecular modeling application, which the whole thing was written using the Tkinter via Python. And in fact, the entire program was written in Python. There's some nice documentation available online to teach you how to use it. There's some additional widgets which were developed to extend the basic widgets that come with Tkinter. But my general advice would be, if you intend to sort of develop a project and build it up, if you intend to develop a larger project and maintain it for a while, you're probably better off using Qt. If it's something you're just going to do pretty quickly, and it's just going to be like one simple one window with a little user interface in it or something like that, then Tkinter may be an easier approach. So one of the nice things that Tkinter includes is a bunch of modal widgets. A modal widget is basically a window that pops up on your screen, and it won't let you do anything else until you respond to it. That's what the term modal means. So this is useful for things like asking the user what file they want to open, presenting the user with a question like, do you really want to do this, yes or no, or asking for a color or something like that. So there are a number of these modal widgets built into Tkinter, and we can demonstrate these quite easily. You don't even really have to write a complete TK application or complete Tkinter application to make use of some of these modal widgets. All right, so most of what we're going to do today, we're going to do within the context of the writing a Python program. You can't really use most of these GUI toolkits from inside Jupyter Lab notebooks, aside from the last one, which was designed for it, because the Jupyter Lab session is already running a user interaction loop itself, and the other GUI tools that open outside the web browser interfere with that process. So don't try to use these things within a Jupyter Lab notebook. However, we can open a Python file. So here I've just, I've got a test.py. It's an empty file. Instead, if I wanted, I could have hit the plus button, and then I could have said new Python file. And now I've got a little editor here where I can edit my program. And then using the plus thing here, I can open a terminal window. Let's see, activate conda. Then I can basically switch back and forth between these very quickly and run my program. So I'll edit my code here, and then I'll run it here. It's not quite as easy as doing the shift-enter thing, but it's still pretty efficient. So let's try this. So we need to import Tkinter. In this case, we're going to be playing with the file dialog. And we'll just do one simple example here. So we're going to say name equals file dialog dot ask open file name. I think that's correct. So we'll save that file, and we'll say python test.py. Oh, I guess it didn't want the argument there. We'll just get rid of that. There is some way of modifying what question it asks or whatever, but it takes another step. Okay, now as soon as I run my Python program, it opens a file dialog. You'll note that it also opens this other window over here. This other window over here is the main window for the TK application. So if you use one of these widgets outside the context of a normal TK application, you're going to see this funny extra window appear. It'll go away when you exit your program. You can just ignore it. But you can see it open a file browser. I can scroll through here, and I can just pick some program, double click on it, and oh, I didn't actually print the results, so maybe I should do that. Do that again. So I can pick some file, and you can see it prints out the full path of the file on the screen. So it gives you a nice way of asking the user what file they want to operate on or something like that. Next one, TK message box. This has a variety of different modal widgets, which lets you ask yes/no questions, or let you ask generic questions with multiple answers, or just show warnings or show errors, that sort of thing. So let's try maybe a yes/no question. Right, and you can see pops up this box alert. Oh, where's the "Are you happy"? Huh, interesting. It doesn't seem to have replaced the string by default here. Huh. Well, it worked in general, but I think. Oh, there's a title and a message. I think it was just too small. All right, let's do this. So this is the window title. There we go. Are you happy? So it's not showing a title bar on this window, so you're not seeing the XXXX thing there, but it's giving you the question, are you happy? And then you can say yes or no, and it'll return true or false. The other tools, like asking questions, there are different ways of getting different answers back. You can say how many answers you want to, possible answers you want to provide, and it won't just be true, false that you get back. It'll be one of the choices, that sort of thing. So it's a nice, convenient thing for doing quick error messages or asking simple questions. Then there's a color chooser module. The color chooser, some systems will not work properly unless you're actually running a real Tkinter program. On other machines, it'll be okay, but it will allow you to do what you'd expect. We'll just directly print what comes back. What is it? Ask color. Okay, so it pops up and we get a color standard. This will be operating system dependent, so whatever your operating system is, it'll use the color chooser for that operating system. So I can pick a color, and I'll say OK, and it'll return this tuple, and it will also return it in the hexadecimal form. So you can do whatever you want with the color. So some nice, convenient widgets. Now, it's actually a full graphical environment. It has all sorts of individual widgets that you can control and you can build nice GUIs with. This is the basic structure of any Tkinter program that's not using those standalone widgets. Basically, you have to import the Tkinter tools. Then you say root equals tk, which just initializes the whole system, and it creates this root window. Then you call main loop. Main loop is the user interface loop. So basically, the way any user interface program works is you do a bunch of stuff to set up the user interface, and then you enter the main loop. And the main loop is that everything that happens to the program from that point on is inside this main loop call. So you do all your initialization first, then you call the main loop, and then the only things that happen in the program from that point forward are things that are driven by the user interface. Now, you can do things like set up timers, which will trigger periodic events to occur. So if you need to do some processing in the background or something like that, you can still do that, but you have to have some mechanism to generate an event in the system to allow whatever it is you want to do to happen. Otherwise, it'll only happen if the user asks it to happen. And then when you're all done, you should sort of clean up at the end, although technically you don't really have to do that. It'll clean up itself when the program exits. So we can just do this really quickly. And there. So I'm not going to set up any widgets at all. I'm just going to do the main loop thing. And when we run this, you'll see we get the window, the same window that we got before, and it will sit there and not return until I close the window. When I close the window, then it will end. Oh, and it didn't even like my destroy. When it exited the loop, it automatically destroyed. So destroy is something you probably shouldn't do. Let me just take that out there now. Used to be necessary, apparently no longer. Okay, so here is the simplest sort of Tkinter program, the Hello World program. So this creates a label widget. It sets the text of the label widget to Hello World. It calls pack, which actually puts it on the screen. We'll talk about that in a minute. And then it calls the main loop for the Tkinter. So a Hello World program. And there we go. It's small, but you can see up there it says Hello World. And when I close the window, it will return. Great. All right, so there are a bunch of different widgets. Here's a pretty complete list of the standard Tkinter widgets that exist. So there are buttons and canvases for drawing pictures and stuff, text entry boxes, labels for labeling things in the screens. You can set up menus, a menu system, all sorts of things that you can do with Tkinter. Another interesting aspect of the way Tkinter does things is there's a way of attaching variables to widgets. So anytime the widget value changes, Python will just see a variable that changes. So if you just use that variable in Python, it will represent the current value of the widget. And you can set the value and you can read the value just by addressing the variable. So these double var, int var, and string vars are those variable objects which can change. Now, one of the things that you have to do when you're building a graphical interface is decide where the widgets go on the screen. The simplest way of doing that is using the pack geometry manager, which is why I use that pack command in here. And what pack does is it basically just arranges the widgets sequentially in the window, horizontally and then vertically. So you put 20 buttons in, it'll put them in all horizontally in a row. If it runs out of space, it'll go down to the next sort of line, as it were, and it'll continue packing them. So it's not a very useful mechanism for putting widgets on the screen. It is bare bones kind of, well, just get everything out there. For the most part, you'll probably use the grid geometry manager, which gives you basically an XY pattern tiling of widgets that you can lay out. And there's ways of having the widget span multiple regions or something like that. So if you just picture sort of a spreadsheet, you can kind of lay things out however you like in XY fashion in the spreadsheet. There's also a place geometry manager, which allows you to explicitly put things in different places at XY coordinates within the window. The problem with that is that Tkinter makes use of the widgets that are available on the machine itself. So on a Windows machine, the button widgets may have more padding than they do on a Mac or something like that, which means if you use place, it may look really great on your Linux box, but then when you try to run the same program on Windows, you may not be able to hit that button because it's being covered up by something. So place is usually not recommended, so almost always you'll wind up using grid. Now, if you want to respond to events, Tkinter uses the concept of callbacks. This is a very common concept that's also used in GTK. The idea is when something happens, it will call a function that you define in advance. So here, we're defining the function. This is going to be what we do in response to the event. Then we create a button widget. The button widget has the text, push me, and then the command option sets the callback. So I set command equal to the function that I wanted to call when the button gets pressed. So let's give that a try. And okay, so you can see I got a window with just one button in it. It says push me. Every time I push the button, it prints, you pushed me too far in the console. And when I close the window, the program exits. Couldn't be easier. Okay, a little bit more complicated. Let's say we want to ask the user for some text and do something with it. So in this case, we're creating one of these string var objects I talked about before. And then we create the text entry object, tk.entry here, set its width so we know how much space the user has to type whatever they want to type. And then I attach it to the variable v that I just created here. Okay, so then here, when I call this function, it will say v.get to get the value from this string var and print it out on the screen. Okay, so now I have a text box in addition to my button. It starts out with the value start, which you can see I put here. I said v.setStart. So you call get to get the value, and you call set to set the value. This is some text. And when I hit push me, it will display the text that I typed in the box. So another very simple example. All right, one example here for timers. I mentioned that once you enter main loop, you lose control over the application. So one way of being able to do things automatically is to set a timer. So here, I'm creating this timer object, which after 3,000 milliseconds will call the timeout function. And you'll note that I created a button here, but I didn't give the button a callback. So I can push the button, but it won't do anything at all. So what we should see is 3 seconds after we run the program, it should print a message down here. There we go, it's time. And the button does nothing, and I can close the window, and there we go. Oops. All right, so here's a quote-unquote full example with several widgets and such. Let's put this into our editor first. So this approach that I'm using in having an editor and a console side by side is very useful when you're going about trying to write your class projects. You can use Jupyter to write some basic algorithms and stuff like that, but when you're ready to start putting it together into a program, which you'll actually turn in, this is a very straightforward approach to handle it. You're also welcome to use Spider or whatever else you like that you find to be a useful tool, but this is one good way of doing it. All right, so save that. All right, let's take a look at this. So this is going to give us a quit button. I'm setting the text of the quit button to quit. To quit. I'm setting the foreground color to red. When it happens, when the button gets pressed, it's going to call root.quit. Root.quit is a built-in function, built-in method of the root object here, which exits the program. Then I'll create another button. This button will be a hello button, and it's going to call the say hi command, which is going to open a message box, which is one of those modal widgets we were looking at before. So let's give that a shot. Now, you'll notice that when I created the button, the only thing I did here was gave it the root object. I didn't give it all the other parameters, and then I set the parameters this way later. So this is another part of the interface. You can either initialize it with all the values here. So I could have said text equals fg equals command equals on this line, or I can set them afterwards. It's a good idea to set up most of this stuff before you call pack. Otherwise, the GUI will update it, will display it the original way, and then it'll update itself when you change things. Okay, so you can see we've got a red quit button and a hello button. When I hit hello, it will open a dialog and say hello there. And when I hit quit, it will exit, just like I closed the window. All right, that is, oh, sorry, I have one more. I forgot about this one. So you can actually get Tkinter to interact with the PIL that we talked about when we were doing image processing, basic image processing stuff. So the Tkinter environment is aware of PIL image widgets, which allows you to do neat stuff like build a simple photo viewer app. So let's take a look at this. All right, so let's look at what I've got here. So I'm creating a button, which is a next button, and I'm creating another button, which is a quit button. The quit button is exactly like the way we did it before. Basically, when you hit it, it'll exit the program. When you hit next, it will call the next but function. So this function is going to use some global variables, just because it's pretty much the way you have to do things in Tkinter. It's not very object-oriented. So when we initialize the program, it's going to get a list of all of the files that end in .jpg in the current directory. So it's doing a lister on the current directory, sorting the list, alphabetical order, and then it's reducing that down to only files that end in .jpg. So I'm starting out with this list of file names, and I'm initializing all the variables here. Then when you hit the next but, it increments the image counter. It tries to read that file into an image object using PIL. If it fails, then it will go back to the beginning again. Right? So if you've moved beyond the end of the list, or if it has some sort of image read failure or something, then it'll reset itself to the first image again. Then here it generates a thumbnail of the image, and then it basically creates, let's see, here I created a label widget, but I didn't give it any text or anything like that. It's just an empty label widget. One of the things you can do with label widgets is you can set images to be the label. So it doesn't have to be text. So here, where I say LBL of image, I'm setting the contents of the image, the label widget, to be whatever this photo is. So it's as simple as that. All right, save this and give it a try. And I only have 2 images in this folder, so it's not going to be very interesting. But when I hit next, it will show the first one. Next, it'll show the next one, and then it'll continue to loop like that until I hit quit. So pretty easy. You can write a little image viewer app in just a few lines of code. All right. So there's some nice references for Tkinter here. There's a nice tutorial. Then there's sort of a deeper sort of set of documentation for it. And of course, if you Google, you can find just about anything. All right. Let's move from Tkinter to Qt. As I say, Qt is a professional commercial product. It has very nice documentation. Everything is well formatted. They're doing support for this for people who use it for all sorts of corporate projects all the time. So everything is very nicely set up. So most of the stuff here, you can see it's at doc.qt.io, and you can get a list of all the available classes and all the widgets, and they'll have nice little previews of what all the widgets look like and do and that sort of thing. The method that we're going to be using in my examples with Qt today are based on the Widgets library in Qt. Qt is in the middle of sort of transitioning to a new scheme called QML, which makes it easier to set up GUI environments that will work both as standalone applications and embedded in a web environment. Now you can't use it in concert with Jupyter notebooks at this point in time. It's possible they may do that sometime in the future. And Widgets is very mature, and it's completely debugged. It works very well, and it's not like they're getting rid of widgets. They just added this additional QML thing. But if you're doing something new from scratch, you have to consider whether you want to use QML or whether you want to use widgets. So the way, regardless of whether you're using QML or widgets, the way Qt is set up is it doesn't have callbacks. So one of the problems is, let's say if you're writing a Tkinter program, and you want something to happen when you hit the button. Let's say when you hit the button, you want 2 or 3 different things to happen. Well, you can only set up 1 callback per button. So Qt uses a much more generic system called signals and slots. So the idea is that when you create a widget object, that widget object will emit a bunch of different signals. So it'll have one signal for when the button is pressed. It may have another signal available when the button is released. If you have a text box, it'll have a text box which will emit a signal every time the user types a character, and it'll have another one when the user starts editing in a widget, and another one when the user stops editing the widget. So you can have lots of different kinds of events. And then you can attach each of those events to as many different slots as you like. And a slot is basically like a callback. It's a function. Now, you could do something like if you have a button that you can press, you could connect the signal on that button to a slot on another button if you wanted pushing this button to do something to another GUI element automatically or something like that. So any place you have a slot, as long as the arguments are compatible, you can connect a signal to it. So it's a very nice abstract system, and it's very resilient, meaning if you create a bunch of widgets and then for some reason you remove one of the widgets, if there are things connected to that widget you removed, it automatically cleans everything up for you. So you don't have to disconnect everything before you get rid of stuff. All right, so here's a very basic PyQt5 application. This is analogous to the application the basic Tkinter application. Take a look at it here. Now, it turns out that the version of Qt which is currently being used by Anaconda has a bug on the Mac. So on the Mac, you have to do this before the programs will work correctly. This is a temporary thing. If you update your Qt in Anaconda in a few months from now, very likely this issue will have gone away. But right now it's true. All right, so let's take a look at this. So you'll see that this is pretty analogous to what we had before, except now we're using object-oriented methods. So we're creating a class for myGUI window, and this class is a subclass of QWidget. So QWidget is the basic object in Qt GUI framework. So the QWidget is just an abstract window. If you make a QWidget by itself, it's just a window on the screen with nothing in it. All of the other widgets, the buttons, the text boxes, everything like that, are subclasses of QWidget. And you can make your own subclasses of QWidget. So I create a myGUI window subclass of QWidget. I make an init event, which, if you recall from last week, gets called when the object gets created. And then the only thing that I'm doing in here right now is I'm calling the init method of the parent widget, of the QWidget. This makes sure that the widget is initializing itself. So this is a very common sort of thing. If you subclass an object, usually in the init method, the first thing that it does is it calls the init method of the parent class. I'm not doing anything here. I'm just defining another method in this GUI window object. Then I create, this is the main application. This is sort of like the main window in Tkinter. This is the application which controls everything. So I create an application object. I make a window. I show the window, and then I call exec on the application, which actually runs the code. So let's go ahead and do that. And there we go. There's a nice window on the screen. And when I close the window, just like the other programs we were making, it goes away. All right. So each widget, like I said, has a bunch of different signals and slots associated with it. So for example, for button, the main signals would be clicked, pressed, released, toggled. So this allows you to adapt your behavior quite a lot. If you go for clicked, that means that the user clicked inside the button and released without leaving the button. So if you click inside the button, move your mouse outside the button and let go, that's not clicked. It's only clicked if you press and release inside the button. Now, if you want to respond as soon as the user first presses the button, you can do that. Or if you want to respond if the user releases the button, you can do that. And then there's also a toggled event. You can set buttons to be toggle buttons instead of just push buttons. So you push it and it gets set, and you push it again and it gets reset. So you can respond to any of these events. There are also slots on the button, which lets you do things like change whether the button is set or not set. You can do things like change the size. You can do some screen animations. There's various things that you can do. This is not all of the signals and slots associated with buttons. It's just the most common ones.
Why is it void? Why is that the?
Void. Sorry, void is a C++ thing. It's the equivalent to none, basically. Void, when you declare a function in C++, means that it doesn't return anything. Sorry, all the documentation for Qt was actually written for the C++ side, and that's been mirrored in Python. But there's still, you'll see some C++ stuff around. All right, so here's a slightly bigger Qt5 application. This one actually does something. You can see it's very similar in structure. The only thing I've done now is in the init method here, I'm creating a push button, which says push me, and I'm adding the widget to the window. So this, I'm using a grid layout. You remember how I talked about laying out widgets in Tkinter? You have to do the same thing in Qt. There are different layout managers you can use to put things on the screen. Qt has more of these, and the layout managers can be used hierarchically. So you can make a grid layout, and then inside one square of the first grid, you could put another grid. Or you could use a horizontal layout where everything just gets put in sequentially horizontally, or vertical, where everything just gets put in sequentially vertically. So there's a number of different choices. But again, grid layout is probably the most common. So here, where I'm adding the widget to the adding the button widget, self.but, to the window. Right. So here I create a grid layout. And the grid layout is the layout for my GUI window. Then here I'm adding a widget to the layout, which will cause it to be displayed in the window, and I'm putting it at location 0, 0. So this is the order is backwards. It's y, comma x. So it's row and column rather than x, y coordinates. But I can change the number here if I want to change the relative layout on the screen. And then here is where I make the connection between the signal and the slot. So here I'm connecting the clicked signal to the self.respond slot. And the self.respond slot is just a function that I've written, a method that I've written for my GUI window. And you can see this is going to open up a queue message box, which is very similar to that Modal widget that we saw in Tkinter. And that's basically it. So there we go. I got a window. It says push me. That'll open that hurt. Why did you do that? And I can do that as many times as I'd like. Now note that I cannot push me while that window is open. It's a modal widget, just like it was in the other program. All right. Now I'm not going to say really much more about Qt than that. There are lots of different widgets. There's lots of different things you can do. And conceptually, other than the signal slot thing, it's not too different from Tkinter, which we went in more depth. I will say that there's a program which comes with Qt which allows you to do graphical widget layout, which is actually very nice. It actually allows you to do a certain amount of programming graphically. So you can create things and you can connect signals to slots all within this GUI. So you can lay out all your widgets, and when you're finished, it will write Python code for you, which will make that happen. Or C++ code. So you can make it. You can design it once, and you can write Python code or C++ code or other language code, sort of all at the same time. There's a nice link here to a gallery of some of the various widgets that are available. Also, unlike Tkinter, which always uses the native widget toolkit on a particular computer, Qt actually uses its own widgets for everything. So with Qt, you can achieve the same look and feel across all of the different machines, but it has multiple choices, so it is possible to have Qt look one way on one machine and a different way on a different machine, if that's your goal. Okay. Next thing, so we're working our way down that list. So we've done all of the we've done all of the well things that we're going to talk about, right? So we did pyqt and tkinter. Like I said, I'm not going to talk about these two. Now we're going to move down to in between JavaScript, and then at the end we'll talk about ipiWidgets. Oops, where was I? There we go. All right. If you're writing a web-based application, you have a fundamental choice to make. You have to decide whether the actions that you need to have occur on the page should take place on the client, in other words, the computer that has the web server, has the web browser running on it, or on the server, the computer that you're connecting to get information from. In some cases, there's only one possible choice. I mean, if it's something that requires loading a file from the machine the browser is running on, or something like that, you obviously have to do it on that machine. And if you have to read from a database, obviously the server has access to the database and the client doesn't. So there are things that have to be done on the server side. But there are a lot of things that you might do in a web-based program where you have a choice. You could do it one way or the other. So on the server side, there are lots and lots of different tools available for writing web servers and having web servers respond in various ways to things. We're not going to talk about it today. I will show you how to create a very simple Python web server, but we're not going to talk about server-side stuff in any detail today at all. On the client side, nowadays I would say your choice is pretty much HTML5 and JavaScript. It used to be that Java was very common. It was used for 2 decades, more or less, as sort of the standard platform people used for a lot of corporate web-based programming. And it's still, like on Android phones, right? Java is still a big thing. But it has had so many security issues over the years that most places have kind of stopped using Java outside of the Android environment. You'll still find it in use in a lot of corporate environments and that sort of thing, and it is very good at certain types of things, but in the sort of the web environment, you won't find Java around very much anymore. Flash is gone now, right? It used to be completely ubiquitous. Now the clients have all been deprecated, so you really can't even find Flash around anymore. It's basically all been supplanted by HTML5 with JavaScript. Now there are 2 standard sort of things that you may run across if you're reading about applications, web-based applications: Ajax and Ajaj. So Ajax first came into being about, 18, 20 years ago, something like that. In the very first version of Google Maps, they had to come up with some strategy for displaying dynamic graphical content within web browsers. And before Google Maps, there was really nothing that did that. So Google came up with this strategy where it would only ask for information from the web server when it needed it. So when you clicked your mouse and you dragged in the map, you'd leave a whole bunch of regions unfilled. And then the web browser would say, hey, I don't have these tiles, and then it would get them from the server. So that's what the asynchronous stands for there. So you had JavaScript, which was running on the web browser, and it would, when it needed information, it would make an asynchronous request to Google's server for, say, the missing tiles in the map using XML. Recently, XML, we talked about this one in an earlier lecture. Recently, XML has been sort of transitioning into JSON instead, because it's a little more readable and sort of simpler to deal with, which has led to Ajaj as being, instead of Ajax, as a sort of general methodology. Now, we've been doing this whole class using Python. Well, it turns out that JavaScript actually looks a lot like Python. If you know Python, learning JavaScript is actually pretty straightforward. The syntax is slightly different, and we'll go over some of those differences. So now, you look at this and you say, well, that's HTML. That's not JavaScript. Well, this is HTML with 1 bit of embedded JavaScript in it. So let's take a look at this in a web browser. Okay, now back to our Jupyter Lab environment again. If we have an HTML file, For example, here I have test.html. I have a choice of opening that in either an HTML viewer or in an editor window. So I can open that in an editor window, and I can open it again in an HTML viewer window. So here I can put my HTML code, and this is nicely put together, so as soon as I change this, it actually automatically updates the corresponding HTML view. So this is actually a pretty nice HTML editor as well. Now, there is a little caveat to that, which is that some JavaScript won't work right in these HTML viewer windows here. So when I hit this push me button, it's not actually doing anything on the screen. So there may be cases where you have to actually open the HTML that you've edited here in a regular web browser instance. Oops, there we go. Oh, I haven't saved it yet, sorry. There we go. So now when I come over to to the web browser and look at the file directly, when I hit the button, it says you pushed me too far. And so just like our other applications, you can open new windows and that sort of thing. But a very simple program. All I had to do is use this onClick method in this button object, and then this is the JavaScript code. Okay, so there isn't really much JavaScript here. It's just very basic. All right, let's move on a little bit. Here is a slightly more advanced JavaScript application. Okay, so what this is using is the onMouseOver method, and you can see what this does. Oh, it's not usable. That one's not working either. Oh, here we go. Sorry, you can see you have to trust the HTML code before it'll let you do JavaScript stuff. There we go. So as soon as I move my mouse over, it will change the background color of the page. So you can see what it's doing is this is the JavaScript code here. Window.document.bg color equals red. This is probably the hardest aspect of JavaScript, is that the web browser provides all of these objects as part of the environment. And to do things in JavaScript, very often you have to find the particular attribute that you're looking for. So if you didn't know that window.document was a thing, you might not have known where to find this BG color thing. So there's a lot of those objects that you have to sort of learn about if you want to be good at JavaScript programming. All right, yeah, I mentioned this. This is just, we don't actually need to do this here since we're doing it with Jupyter instead, but you can actually set up a simple Python web server on your local machine, which will serve all the files in your local directory using this little three-line program. Right, so this will import the HTTP server. It will set up a server. It'll use this port number, and then it uses the built-in simple HTTP request handler. If you want to do more complicated things, you can write your own request handlers to do anything you want. So if you want to write your own web server, it's actually pretty easy to do in Python. Not saying I advise it, but it's something you can do pretty simply. So Python has built-in tools not only for doing web browsing and getting information, but also serving information. All right, so here's something that has a little bit more JavaScript code in it. All right, this is a JavaScript calculator. If I type in an expression there, it'll compute it and display the result here. So let's take a look at how that's working. All right, so all of this is HTML code. When we get to script, this is where the JavaScript is starting. So I'm defining a function. You can see this is like def. So this function statement would be just like def in Python. I'm defining a function called compute. If the key code is not equal to 13, that means 13 is the carriage return character. That's what happens when you press enter. Then it just returns immediately. If it is 13, then it continues. And what it does is it gets get element by name data of 0. So here I defined an input box, and I gave it the name data. So here, this is the JavaScript code for returning the value that the user typed. Then I put the result in. So here is the result box here. So in result, I get access to the result object, and then here I set its value equal to eval data.value. Python has this too. Basically what we're doing is we're giving the user a box where they can type any JavaScript code they want, and it'll execute that code and put the results in this box here. We're calling it a calculator because I can type math there, and JavaScript can do math. So this is really sort of a cheat, and it's not really a very secure way of doing things because it lets the user run any JavaScript code they want. However, JavaScript is running on your web browser, not on the server, right? So the only machine you would be able to impact by running that code would be your own computer anyway. So it's not, particularly a problem. Anyway, so this is a very simple sort of JavaScript program. Here's a slightly more complicated version. Now, I'd like to point out that this is not a robust calculator. It's just something to sort of give you an idea of how things will work. It's a couple pages long here. We'll try it first, and then I'll explain it. So if we go over here, oh look, I've got a little keypad. I can type 55 plus 6 equals 61. So it seems like that wasn't a very long program to create all of these different buttons and have them actually act like a calculator, right? I mean, it's only a page or so of code. All right, so here I created a HTML layout matrix. One of the nice things about HTML is it's designed for laying things out on the screen. So we use that for deciding where everything goes. So here's where I create all the buttons that do various things. And then I have onClick. So when you click the button, it will call this JavaScript function with that parameter, right? So when I press the 7 button, it calls num with 7. When I hit the X button, it'll call fn with star. So what happens down here? If you call num, it basically adds the number that you typed to XPR, to the variable that you're using to build up whatever number the user is typing in. If I call function, then it adds that function to XPR, XPR being an expression. And then when you press the equals button, it does the same trick we used before, eval. It calls eval on it. Okay? So again, this is kind of cheating. We're not writing all the code, the logic necessary to do a calculator. What we're doing is we're building up a string by pressing all these buttons, and then we're evaluating the string. Okay? Anyway, so that's just another fun little JavaScript example. So this is just a quick syntax summary for JavaScript. So when you want to declare variables in JavaScript, you have to prefix it with var. You can't just say variable equals x. You have to say var, and then you can put the name of the variable to define it, or you can put the name of the variable and initialize it with something. To define functions, you use function instead of def. If looks very much like Python, except there's no colon after it there. It's just if the expression has to be in parentheses, and after the closed parentheses, you can just put your statement. JavaScript supports semicolons, which are a thing from C. In Python, you end a statement by going to the next line. In C, you end a statement by putting a semicolon. So you can put a whole bunch of statements on the same line in C, separated by semicolons. JavaScript does both. So in JavaScript, you'll note in this program here, I just had one command per line, and I was using and I indented, but that wasn't necessary. I just had one command per line. That's fine, but you can also put semicolons in and put multiple statements per line if you'd like. Now, the replacement for the colon in JavaScript is curly braces. So this is another thing that was drawn from C, C++. So it doesn't matter how I indent my code here. I don't have to put this indentation here. What matters is the curly brace here, which starts the block, and then there's a corresponding closed curly brace here, which ends the block. So that curly brace thing is common across many, many different programming languages. So Python is kind of the outlier there. Then we have do, while, and we have while, and we have for loops which work like Python, and then we have another kind of for loop which works like C++. We have switch, which is a way of doing if, else if, else if. It's sort of an alternative way of doing that. This is also drawn from C++. But this is really just all the basic syntax for the JavaScript language. So if you know Python, it's pretty straightforward to learn how to do basic JavaScript programming. The hardest thing is learning all those variables that you have to deal with. Now, this page lists some of the most common things that you can do which link the HTML to JavaScript. So when you create elements in your HTML page that have functionality associated with them, you can use these various methods. These are the various actions that you can take that you can then link to JavaScript function calls. So clicking, focusing, blurring. Focus means that you started editing like a text string or something like that. And blur means you stopped editing the text string. Mouse down, mouse up, mouse over, all sorts of different things. Okay, that's it for JavaScript. Now our last thing is doing simple user interfaces inside Jupyter Lab notebooks. So we're going to use something called, so the first one here is just a simple HTML capability. So we'll demonstrate this first. Basically, you can call this display HTML method, and it will print a single HTML screen. Now you can't really do JavaScript very well here because Jupyter, the notebook is already doing its own JavaScript to sort of control how the page works. And if you try to do JavaScript yourself here, it will tend to interfere. So if you want to do JavaScript in this context, you have to really know what you're doing and learn about how Jupyter Notebooks works internally. So that's the simplest thing. Now ipiWidgets is what I put into the easy category. If you want to make simple interactions with your Jupyter Lab notebooks where the user can adjust parameters or something like that, this ipiWidget system is the standard way of doing it. For Anaconda, you shouldn't need to do this anymore, but if somehow your ipiWidgets don't work right, these are the two steps that you might have to take to get them to work. All right, so here's a simple example. So I'm importing these various methods from ipiWidgets. I'm going to declare a simple function which takes 4 parameters, and all it does is returns the 4 parameters. This is where all the magic takes place. I call interact. I give it the name of the function that I created here, and then I give it values for all of the parameters that I want to pass. Now, what's going on here? Depending on what I pass in for each of these variables, it will cause ipiWidgets to automatically act in different ways. So when I execute this, you'll see that the 0, 100 here gives me an integer slider. The 0.0 to 100.0 gives me a floating point slider. A single string gives me a block of text where I can edit. And a list of strings will give me a list of choices as a menu. And you can see as I change each of these things, this immediately changes. So this interact is sort of continuously running in the background on the machine. So anytime I manipulate any of these widgets, it will call f again with the set of the 4 values that it's gotten from these widgets here. So this makes it really easy to do some really complicated sorts of things. So here's a nice little example for doing Fourier transforms. Okay, so what are we going to do here? My function g, well, I'm printing out the value that came in first. That's not necessarily useful. It's just to show that it works. So I'm using NumPy to create a range of x values. I'm using NumPy again here to take the sine of those values multiplied by q that came in. So this is basically sine of x times q, which means that I'm varying the frequency, the periodicity of the sine wave. Here I call the NumPy FFT library to compute a fast Fourier transform of the array y. And then I'm here using matplotlib to generate graphical output. So let's run this and see what happens. All right, so I've got two plots here, and I've got a slider. And as I grab the slider, it'll change the periodicity of the sine wave. So what I'm looking at here is the actual sine wave in real space. And for those of you who know what Fourier transforms are, this is the Fourier transform of that sine wave there, which basically corresponds to the position of the slider. Now you can see there's a little flicker there as this runs, and there are a couple of ways of avoiding that. But aside from the flicker, we've just made a nice program where we could, grab sliders and do stuff. We can make this maybe a little more complicated. Okay, let me run it first and then we'll take a look at it. So here now you can see we've got two sliders, and what this lets us do is generate two frequencies which are being multiplied by each other, two sine waves that are being multiplied by each other. And I can look at the Fourier transforms as well. All right, but you'll note I did this in a slightly different way. The function is very similar to the function that we declared before, but now instead of saying up here, you saw I said interact here. Here I said interactive, and that returned an object. So when you say interactive, it creates an object which you can then display inside the Jupyter Lab session. So when I say P here, that's what's causing the object to actually be displayed. If I put P here, I would get another instance of the same object here, which I can then interact in the same way. So interactive makes an object which you can reuse, and interact just does a one-time setting up of all the widgets and stuff. Right. So there are a lot of widgets available in the system now. This has been growing over the years. I think I've got them all here, but let's just take a look at the full suite. We'll just do it here. Okay, so here are basically all of the different widgets that are available. You can see we have drop-down boxes. We have these push-button tab boxes that you move up and down. We've got lists where you can select multiple items. Lots of different things. Now, you'll note one difference here. Here, all I did was I passed in this range, and I allowed it to decide what sort of widget to use itself. If you want to be more explicit about it, you can. So here you'll notice that I said v1 equals widget.floatRange slider, widget.bounded text, etc. So if you want, you can actually specify a specific widget that you want to use instead of just giving it values. But if you don't care, if you just want to have some way of changing it, usually its automatic choice is pretty good. All right, so this is really useful for casual sort of programming sorts of things, right? It's not so useful if you're planning to give it to someone else. This ipiWidgets, if you passed it to your buddy, he may have installed Jupyter for himself 2 years ago when he took this class, and he may have a really out-of-date ipiWidget, so you may have to do a whole bunch of updating to get any of this to work right. It's not all that version cross-compatible, but within your own system and your own environment and stuff like that, you can make stuff that'll work for yourself really quickly and easily. So it's not so good for robust applications, but it's great for just sort of quick one-off sorts of things that you might need to do for yourself in the lab. Okay, that is basically it for this module today.